Worksheet 14 talks about writing an equation for a rational function. We haven't done this before. It's an old worksheet, I apologize. It's oldie but a goodie. Tell me what you think you can tell from the graph in terms of what might be a factor in the numerator or a factor in the denominator. There is an asymptote at x equals 3. That means there is a factor of x minus 3 where? In the bottominator? Okay. What makes things factors of the numerator? How can you tell when things are factors of the numerator? Yes, the zeros. And what can you tell me about the zeros? So a factor would be x plus 3 and x minus 4. Yes.
I think you need to square both of them.
I think John is right that we should square both of them. That's written really messy. Because they bounce at both of those places, right? Everybody good? It's bouncing? Okay. What degree do I have right now? The numerator is degree 4. The denominator is degree 1. When it's top heavy, we would have to divide it out. If we divided an x to the 4th by an x, we would get what? X cubed. Does this look like the far ends are doing a cubic? No. Okay. Do you remember a really weird thing I talked about last week? I said normally on either side of an asymptote, the graph is going one way up and one way down. Okay? Yes. So, does this doing that on both sides of this asymptote? No, both pieces are going up. Okay? So what we need to do is, let's try squaring this factor in the denominator. And then we're going to type it in and see if we get the right shape. But before we do that, there's an extra point here. Guess what? We need to use that. Okay? What is this telling us? When we put in a what, we should get out a, put in a 0, we should get out a 24. Okay, thank you. Michaela, this is for you. I'm just going to lay it here because I'll forget, okay? We're trying to figure out if there's a stretch. So it would say 24 equals the stretch. Put a 0 in, and we'd get 3 squared times -4 squared. Denominator would get -3 squared. What's a 3 squared? -3 squared? So can I just divide those out? Yeah. Okay, on the top, -4 squared would be 16. If we divide that, we get 24 over 16, or 1.5. Yeah. And I was lazy and went with 1.5 in the numerator. You could put a 3 on the top and a 2 in the bottom. Okay. All right, to try this, we need to put a giant parentheses around the top and type this in. See if it works. Well, I don't know about you, but when I type like a 3rd and 4th order of parentheses on my calculator, they do get really big. Okay, so go parenthesis, 1.5 parenthesis, x plus 3 squared, x minus 4 squared, close the whole top, divided by x minus 3 squared. Now, the other thing you should do is you should set your window somewhat close to what they have. I left my x -10 to 10 because it wasn't going to change it much, but what is their y window? 100. -25 to 100. Okay. Then graph it. Now, this isn't going to show up for the recording at home because I didn't bother to do it on the online one because it takes forever for me to type that in. But if I turn the document camera on, this is what I got. What's it looking? Pretty darn good. If I do trace 0, I get 24. Perfect, right? All right, you guys pick one more. Which other one would you like us to try together? 2? Okay, number 2. Oh, we need to go back. Wait a minute. What? Yeah. I forgot we didn't do the limits, okay? The limits, the first one says the limit of y as x approaches negative infinity. So as I go off to the left forever, this thing is going where? Wait a minute, wait a minute. As x approaches negative infinity, y is approaching infinity. Okay, that's what we need there. The second one says as x approaches positive infinity. So as we go off to the right and get bigger and bigger, y is getting very big in positive infinity. Now, this is new notation. This means as you approach 3 from the right, the positive behind the number means from the right. This one means 3 from the left. Does it matter for this question whether we're getting close to 3 from this side or close to 3 from this side? Both ends are going up. So they're both approaching infinity. Actually, all 4 arrows are going up on this graph, so everything was just approaching infinity. But let's talk about number 2. We don't have to do number 2. Somebody said they want me to do 4. That's fine. But just talk about these last, if you need to go get a drink, you can. These last 2 down here. This is a really important concept in calculus, guys. As you get close to 4 from the left, so if I was writing on this graph, coming in close to 4 from the left, where would I be going? Yes. Whereas if I was coming from the right, getting close to 4, I would be going up, so I would be approaching positive infinity. Does everybody understand the difference? From the left, from the right. Okay? It's a dance move, right? To the left, to the right. Okay. What do we want me to do? 4? Okay. Number 4. What can you tell me about the numerator or the denominator? You pick. This is an asymptote. It's just not dotted. Should be. X minus 3 and x plus 2 are in the denominator. Either of those squared. What makes an asymptote factor have a squared? No, numerator bouncing. Denominator squared if on either side of the asymptote it's going the same way. Either both up or both down. Over here, this red asymptote, left side is down, right side is up. But over here at the asymptote at 3, both sides it is going up. So the one at x minus 3 needs a squared. That's a weird thing that you just would have to practice and figure out. So I'm just pretty much telling you, okay? Now, yes, on either side of this red asymptote, on the left side the graph is pointing down, on the right side, right next to it, the graph is going up. If over here, like at 3, on the left, the graph is going up, and on the right, the graph is going up, that means that asymptote had a squared on it. Yes, both sides are going up. There is not a question like this on the test or the quiz, okay? And actually, I will tell you on the homework check, all I did was give completion points for this worksheet. So if you've done all 4 of them, you'll be fine. Yes.
You could say they're bouncing off through the asymptote.
Yes, they're bouncing and going up, staying going up. I don't know. Okay. What can I do for the numerator? What can you tell me about the numerator? I think this is supposed to be -6 and +6, so what does that mean? It has a 0 at both 6 and -6? Right now it's degree what over degree what? Degree 2/3, which is bottom heavy. Bottom heavy is y equals 0. Does this seem like the asymptote is out here at y equals 0? But do you remember a horizontal asymptote it can cross, but is it staying close to 0 here? I think it is, but that doesn't mean we're finished, unfortunately. We gotta try this stretch business. Okay, we get out of 40 if we put in a 0. 0 plus 6 is 6, 0 minus 6 is -6. 0 minus 3 squared, 0 plus 2, oh, not squared, just kidding. -36a over 18, which is? Anybody get an A? A equals -2.
Oh, no.
20?
Yeah, 20.
We did get a -2. When we divide, we get 20. There we go. That seems okay. Now, did that change our end behavior by putting that 20 in? Is it still bottom heavy? It's still bottom heavy. Does bottom heavy affect the leading coefficient? Doesn't mean do if as long as it's bottom heavy, it just approaches y equals 0. All right, you can type this in and check it. I think it's going to work. You need parentheses around the whole top and the whole bottom since there's more than one factor in the denominator. Can we do these real quick just so I'm sure you get this? Far left, it's at? Nope. By so? 0. Isn't it staying right by 0? That was our end behavior, right? Far right? 0. -2 from the left. So as I ride on this graph and I go towards -2, I'm going down. But as I get close to -2 from the right side, it's going up. And at 3, both sides of it are going up. All right, got it? At the end of the period, I will come back to this, and yes, if you want me to do another one, I can. Right now, I need you to switch over to worksheet 16B. It's on the very back of everything I gave you today. On the back of everything I gave you today is the quiz preview. This is for tomorrow's quiz, guys. Did everybody find this on their desk? Okay. Tomorrow's quiz is one sheet of paper, front and back. There are 3 questions like this first example where you're going to want to factor, find the domain, vertical asymptotes, horizontal asymptotes, zeros, and y-intercepts. Zeros and y-intercepts need to be written as ordered pairs. Domain is x cannot equal. Vertical asymptotes are x equals. Horizontal asymptotes are y equals. We're good? You may use the gold one-sided reference sheet. Does everybody know what I'm talking about tomorrow? And you may use your calculator. Any questions about those? Yes.
Do we use both of those for the test as well?
I have not made a decision about the reference sheet. You definitely will be able to use your calculator. I will make a decision after tomorrow's quiz. All right. There are 3 graphing problems as well tomorrow. A rough sketch is what I'm looking for, with the exception that asymptotes and end behavior should be accurate. Okay, holes, if there is one, zeros, those things should be accurate. But as far as, you know, all the points in between, just a rough sketch is fine. It will say end behavior, and it will say intercepts. So this is both the the X and Y intercepts here. So, okay. Vertical asymptotes, I think there's 2 on this one. I don't think there's a hole. End behavior, this one is bottom heavy. But if it was top heavy, what might you have to do to find the end behavior? Or what will you have to do if it's top heavy? Yes, you have to divide. Synthetic or long division? Probably synthetic. Okay? So the end behavior equation could be y equals 2x minus 3. Who knows? For some. All right, any questions on that? There's a question or two that says find the hole. All you have to do is tell me the x value where it occurs. I'm not going to make you find the ordered pair. All right? How do you know there's a hole? Factor the same numerator and denominator. Whatever would make a 0 numerator and denominator is where the hole would exist. All right, this is review. Polynomial function, not a rational function, so no denominator, of degree 6 with x-intercepts at 7, 0, and negative 2. You want me to do that one, or you want me to make up another one? We can just do this one? What would that look like? Anybody? X minus 7. Okay. Is that the answer? Can you throw some more zeros on the back? It says only. Okay. Could I square all of them? Will that work? That makes it degree 6. Is that what you have to do? Could you do the first one to the 4th and these to 1 power to the leave those as linears? No, because then it wouldn't.
It's supposed to be a 7, not a 4.
That's a 7. Thanks. Yep. All right. The question like this on the quiz is like this one, okay? But what if maybe on the retake of this quiz, if you have to take it, instead of x-intercepts only, it said with zeros at 3, 4, and negative 5i. Well, it would have an x minus 3 and an x minus 4, right? If it has a 0 at negative 5i, it has to have one at 5i. If I wrote those, x minus 5i and x plus 5i, and if it said real coefficients, you'd have to FOIL those together. Anybody know what you're going to get?
X squared.
Plus 25. Okay. What are we up to? Degree? 4. If it had to be degree 6? If I squared those, then they'd have 2, 4, and this one's already got a squared, so that would be 6, right? Okay. There are other options to get up to 6, but that would work. You could just square this one. You'd have a 4, 5, 6. All right. Just covering all the possibilities there. And there is also a review long division question tomorrow. Does anybody need me to do that, or we're good? Some of you struggling with this still? 3x squared plus 2x minus 1 into 15x cubed plus 22x squared plus 3x minus 15. Okay. You look first only at this term and this term. Everybody said 5x because that's how many times you got to multiply that by a 5x and you'll get exactly 15x cubed. This is where some of you run into trouble. That's all you do. The rule is when you long divide, you figure out how many times it goes in and then you multiply. Well, we have to multiply 5x by all of those terms. So I get a 15x cubed plus a 10x squared minus a 5x. Everybody okay with where I came up with all three of those? Then some of you always mess up your signs. You're subtracting. So you get 12x squared plus 8x minus 15, I think. All right, look at the first term only again. Just a plain old 4, right? So then multiply everything by 4, and you get 12x squared plus 8x minus 4. Change your signs. And all you have left is a negative 11. Did I do that right, guys? Okay, so you'd have minus 11 or plus a negative 11 over that whole mess. All right? If you do the review tonight and you want to check it after school or before school tomorrow, I made a bunch of copies and put them in the bin over here of my answer key to this quiz practice so that you can check them.
Should we check it before the quiz?
Yes, that's why I said after school or before school tomorrow.
Oh, I thought you meant like after school tomorrow. I was like,
No.
what?
That would be kind of a waste of time.
I was like, wait, is she changing the quiz?
No.
No.
I don't know, maybe I did say it wrong, but that's what I meant. All right, I am moving on to worksheet, I don't know what this is. Somebody help me. 15A, 15A. We're only gonna do one side of this, worksheet 15A. Okay, this is about nonlinear inequalities, and by nonlinear inequalities, there are two things we've talked about in this chapter. We've talked about polynomials, so big long x to the fourth plus 3x cubed plus 2x minus 7, okay? Polynomial inequalities, so with a greater than or a less than or greater than or equal to or less than or equal to. And we've also talked about rational functions, big old messy things with denominators, right? And those can be greater than, equal to 0, less than 0, etc. We used to spend almost 5 days on this because there are messy rules for all this. Talked to Miss Gupta, she said, if they can do it on their calculator for calculus, that's all we need. So, we're going to use our calculator. We're going to solve these by graphing mostly. We are today only going to talk about the polynomial ones. And then Wednesday after the quiz, we'll address the weirdo rational ones with denominators and stuff, okay? Today's lesson is really easy. We're going to go quickly through this. If you have a big nasty polynomial and you graph it, okay? You don't have this, so just look up here. If I graphed this, it would show me that I had a 0 at, can you tell, is that -4, -2, 2, and 5 maybe? Okay? Where is this graph less than 0? What values of x make y less than 0? Well, out here the graph is what? Above the x-axis. In between these it is negative. In between here it is positive. In between these it is negative. And out here it is negative. Which of those work as less than 0? Okay, between -4 and -2. Anywhere else? Between 2 and 5. Anywhere else? 5 and infinity. It's still below. Can I just ignore the 5 and just put 2 to infinity?
No.
Unfortunately not, because it says less than 0. And at 5, it's actually equal to 0. If we change this to an or equal to, then the brackets would change here, and it would become all values from 2 to the right. All right, so we're going to this out with a couple questions on the homework. This is on your notes, the top of the worksheet. Notice it is not compared to 0. We want to make it compared to 0 if at all possible. So we're going to make it say x squared minus 3x, subtract that 3 over there, and it'll be a minus 18 is greater than 0. Everybody see what I did? Factor. So what is this graph? If I were to whip out my calculator, which is no need for me to do, where's it going to have zeros? Negative 3 and 6. And what shape is it going to be? It's a parabola that opens up. So do I already know where it's positive and where it's negative? Okay, it's positive out here, it's negative in here, and it's positive out here, right? Above and below the x-axis. So the question said, where is it greater than 0? It is greater than 0 over here. Negative infinity, negative 3. And to the right over here from 6 to infinity. Now, we used to do what's called a sign test, which I kind of did for you up here. But before we had graphing calculators to look at, a lot of times we had to test a value out here, test a value in here, test a value out here to decide if it was positive or negative. Parabola, not so much. Even old people like me knew a parabola that opened up was going to be negative certain places. But if you had crazy rational functions like we're going to do tomorrow, we had to test things. We're going to just use our calculator to test them. All right, I want to give you an example of a strange one. This says graph x squared plus 2x plus 2. You get this parabola. It doesn't ever touch the x-axis. So if it said this, what's the answer going to be? What is that symbol? Less than 0. That's what I was afraid. Some of you still struggle with that. This is the letter L squished over, yes? That is a less than. Okay? So this is less than 0. Where is this graph less than 0? Never. So it is no solution. If the question had said greater than 0, you would have said all real numbers are negative infinity to positive infinity. All right, we are going to do this question now. I changed this question and I messed it up. I changed it so that we could factor it, but does this factor? No. So we're going to do this on the calculator. Yeah, I think it was supposed to be a +2 when I made, because it had a cubed in it and I didn't want to start out with a cubed. We're just going to do it by decimals because I'm fine with that. Type it in your calculator and find me the decimal solutions. Or you could use the quadratic program. Quadratic gives you that, but somebody tell me what the decimals are.
3.561552.
Okay?
Negative 0.56.
All right. So here's the x-axis, and there are the zeros. What is this graph? It's a parabola that opens up. And this symbol is a less than. So where is this true that it is less than 0?
Negative 0.562.
Yes, in between those values. If you were writing exact answers, since I screwed it up and you would need to do quadratic, it would say this. But I'm okay with decimals because I didn't mean it to be that ugly. All right, let's try one that's not so ugly. Number 2. Does that factor? X plus 1, x plus 1. What does that tell you? It bounces at -1. Well, what does that mean? this opening up or down? It's opening up and it bounces, means its vertex is actually at -1. What does this say? Greater than. If it said greater than or equal to, it would be all real numbers. Unfortunately, it only says greater than. So it can't equal 0. So we got to go everything to the left of -1 and everything to the right of -1. But it can't include -1 because at -1 it's actually equal to 0. If we had just said or equal to, then it would have been -infinity to infinity. Two more? Number 3, what do you want to do first on this one? Don't say cry. Don't say take an X out, actually.
Subtract 12.
Yeah, we want to make it compare to 0 first. And then we can't take an X out. The problem with taking an X out, oh, sorry, I wrote that wrong, is you can't say X is greater than 12. You can't separate it. You can only compare things to 0 in terms of, if I had this, which I doubt it works, I'm just making something up. If it said that, that means nothing, right? Because I can't say X is greater than 12, X minus 2 is greater than 12. It doesn't work. You can only compare things to 0 because these don't multiply to make 12. All right. I can't factor that in my head, but if I graph it, I bet I can find out where the zeros are really fast. Okay, any bounces? No, because it started out as degree 3. Okay, I don't have my calculator even turned on, but if I believe you that those are the zeros, do I still know the shape? Because it's a cubic, right? Is that the right shape? It may go up a lot higher, down a lot lower than that, but it doesn't matter. Greater than means what?
All numbers greater than.
So where it's positive here and out there. Answer in interval notation, anybody?
-4 to -3, union 1 to infinity.
You guys are good. All right, last one. You try the last one on your own? Yeah, factors, it's not anything tricky, I don't think.
Yeah. Yeah. The one on the right.
This one's better if you do it by factoring. Otherwise, if you use your calculator, you get a decimal. I would probably live with it because we're supposed to just be able to use our calculators to do these. But what is 0.66667? Yeah. So we have a 0, positive 2/3 and -1. Did I factor it right, guys?
Yeah.
Okay, it's a parabola that opens up. So where is it doing this? What does this say? Less than 0, which is in between those values. Okay, so if you have everything done with the homework for the homework check tomorrow already, and you have the worksheet 16B, the quiz preview done, and you have no life, and the Cubs don't play, and you have no homework tonight, feel free to work on 16A. Okay, 16A, and the chapter review assignment, which is on that gold sheet. Those are not the priority tonight, though. The priority is the homework check and the quiz, okay?
What?
Can we do
15,
one more on
16?
14?
Oh, the priority?
No.
Software?
Yes.